Calculus was created to describe the dynamic nature of our universe. Isaac Newton developed calculus to help him explain the laws of motion and gravity. Differential calculus examines the rate of change of a quantity, how the position of an object changes compared to time. Differentiation is important in the natural sciences, engineering, and technology. Over the past few weeks, we have learned the product, quotient, power, and chain rules. These skills will help us examine several real-world examples to illustrate the importance of differentiation. To see the power of differentiation, we're going to use this tennis ball, and from the parabolic pathway that will result when I throw it, we'll be able to determine its highest point using differentiation. Let's take a look. In the video, I threw the ball from 6 feet. The ball was in the air for about 2.38 seconds. The acceleration due to gravity is 32 feet per second squared. Using the equation for projectile motion, I determined that the initial velocity was 36 feet per second. By doing so, the ball's parabolic equation is h of t negative 16t squared plus 36t plus 6. Taking the derivative, d of h over d of t, we get negative 32t plus 36. At this point, we're going to take that derivative and we're going to set that equal to 0. That will determine our maximum point because the way in which the parabolic, the path of that ball traveled. We take that and we take it and set it equal to 0. We get negative 32t plus 36 equal to 0. We'll get t is equal to 1.125 seconds. At that time, we plug that into the original equation in which to set it equal to t, and we'll get 26.25 feet. That is going to be our maximum point. Now, when we do it, you can see here, y is equal to 0. We set it, the line across, and you'll see we hit 26.25 feet. And this is the pathway of the ball graphed. Going forward, we'll use a second derivative test to confirm that that would in fact be the maximum point. We took the second derivative of this negative 32t plus 36 and we get a value of negative 32. That is less than 0. That's a maximum point because being less than 0, it's concave down, and that would be the maximum point. At this position, we're going to have a few questions to determine for ourselves. One question is, what is the height of the ball at 0.5 seconds and at 1.5 seconds? Take a few minutes to figure that out. Now the solutions of that, we go to our original equation, we plug those values in. 0.5, we plug it in, we get a value of 20 feet, and we plug 1.5, we get 24 feet. Now you can see in our graph, at 0.5, this would be 20 feet, and the value at 1.5 would give you a value of 24 feet. We saw the parabolic pathway formed by the tennis ball. Now we're going to do another parabolic pathway using a 100-gram weight attached to a rope attached to the doorway. We're going to launch it at 3 feet in 3, 2, 1, launch. From the video in which we saw the parabolic pathway of the 100-gram mass, which was attached to a string that was attached to the doorway, we launched at 3 feet, and it took 1.3 seconds to get to the other side, the apex of the other side. From that information, we determined that h of t is equal to 7t squared minus 9t plus 3. The derivative of that would be dh over dt is equal to 14t minus 9. We set that equal to 0, and by doing so, we will get the time at which we hit our lowest point, our minimum, which would be 0.643 seconds. We will then take that 0.643 seconds, put into the original equation for the parabola, and in doing so, we'll get a value of 0.107 feet. We will know by taking the second derivative that that in fact would be the minimum, because the second derivative is going to be a value of 14. We know that the second derivative test, if that value 14 is greater than 0, it's the minimum. It's the minimum because this would be concave up, and that would detail the minimum. Knowing from that information, we go to the graph of that 100-gram mass that was launched at 3 feet. As you can see, when y is equal to 0, we hit that point right here, and that point right there is going to be a value of 0.107 feet. And that is the minimum of that graph. Now, to ensure that we have mastery over this information, I'm going to assign the students to work in groups of 2 in pairs, and I want students to work on the following question. It will be a tennis ball is thrown in the air, its height h in meters at a time t in seconds is given by the equation h of t is equal to 5 plus 12t minus 3t squared. I want students to determine what is the ball's maximum height, prove that that point is the maximum, and graph the pathway of the ball. I'm going to walk around the classroom as students work to check on their progress, to answer any questions, specific questions, and to make mental notes of issues that they run into. I will walk around for 10 minutes.